right, guys, we are back at it again with another video. We are starting activity 3. So we're doing 3-1 today, where we're going to be solving systems of 2 equations. Okay, so today we are just doing day 1, where we're going to be solving systems by graphing. So graphing only today. So make sure you have your Springboard book, okay, open to page 29. Something to write with, and a calculator or some way to kind of help you do some graphing if you need it. Okay, so we're going to be using graphing to solve systems today, and then we're going to do some real-world applications at the end here. So on page 29, I'm just going to kind of skip to this bottom part down here. Okay, we're going to kind of skip that scenario, and I just want to talk about how you find the solution to a system in a graphical sense. Okay, so the solution of a system of two equations is when the coordinates of the points make both equations true. So that's just a fancy way of saying the solution is where the graphs intersect. Meaning where the two graphs cross each other. So in this particular picture, here's where the two graphs would intersect each other. So at that ordered pair, that x comma y, that is our solution to our system. So we always write our answers as ordered pairs for these. So you have to have an x answer and a y answer. Okay, but today, since we're graphing, we're just going to pick out that ordered pair, and that's going to be our solution. Okay, so I'm just going to jump to question 3 here. We're going to come back to question 2 and why it's important, but we're going to graph the equations in parts A through C and look at how many solutions we have for this system. Remember, a system just means you have 2 or more equations in one problem. Okay, so we've been doing a lot of work with graphing lately. So let's make sure we're graphing this in slope-intercept form, meaning we start at that y-intercept. So we start at +1. And then the slope tells us our rise over run, right? So we have a little imaginary coefficient of 1 in front of there. So 1 over 1 means I go up 1 and over 1. Like this. Now, the more points you put on there, the more accurate your picture will be. But here we go. So there's our first line. Okay. Our second equation, we have negative x plus 4. So I'm going to start at +4. Okay. And in negative x, we're going to go down 1 and over 1. Okay. Connect your dots with a nice straight line, pulling that graph all the way through your xy plane. Don't make any dinky little short lines. Make sure you extend it all the way through the graph. Okay. So then if I look at this, I need to find the intersection point in order to know the solution. So it looks like we have one solution because the graph crosses one time. Okay. So in this particular problem, we have one solution. Now, because these lines didn't cross at a nice spot, I can take my best guess where I think they cross, but I don't actually know for sure just based off this picture. But let's say it looks like maybe 1.5. And the y looks like maybe it crosses at 2.5. Okay. So that's just my best guess, okay, because it didn't cross at a nice spot, but there we go. So that had one solution, one intersection point, okay. Now remember, you could always use like a graphing system to help you do that. You can use your graphing calculator since these are both y equals and calculate an intersection. Or remember, you can always use that thing Desmos that I've been showing you a few times. If it loads. Okay. So our two equations here, where y equals x plus 1 and y equals negative x plus 4, right? So it looks like my guess was pretty accurate there. I zoom in, okay? So if you click on Desmos, you can honestly just click on the point and it'll tell you straight up what the answer was. So it looks like I had a good eye on that one. Okay. So let's look at B then. So B, we have 5 plus 2x and y equals 2x. So I'm going to graph the first equation here in purple. So I have 5 plus 2x. So this is written a little out of order. If you don't like it, you could switch it around. But my y-intercept is 5. And positive 2 is my slope. So I can go up 2 and over 1. Or I can always go down 2 and left 1, since that one would go off the graph a little bit there. Oop, that's not very straight. Let's try and do that a little better. Okay, so there is one line. So my second equation here is y equals 2x. Now, if you want, you can always put a plus 0 there, since we don't have a y-intercept, it looks like. So instead, we know we're crossing the y-axis at the origin at 0, and then going up 2 and over 1, because we have the same slope. So if I connect those dots, let's look at those two lines, okay? Now, I don't see an intersection point, and we're actually never going to have one because we have the same slope. These are actually parallel lines. Okay, and you could graph it on Desmos and see that even if these lines went continuous forever in both directions, they're never going to actually cross because they're going to have the same rate of change every time. So those points aren't going to cross each other. So anytime you have the same slope, this is going to happen. You're going to get parallel lines. So this is a case where they're never going to intersect, so you would have no solution. So that'll pop up sometimes, but this is a rare case, a special case here. Okay. All right, let's look at this last one. We have y equals 2x plus 1. So I'm going to go ahead and graph that first equation in green, starting at 1 on my y-axis and going up 2 and over 1. So I'll try to connect that as best I can. There's one line. Okay. So in my second equation, I hope you notice that we have a little problem here. Okay. This has a 2 in front of it, so it's not y equals. So let's try and make that y equals. I'm just going to divide that 2 out. So if I divide it on the left side, I have to divide everything on the right side too. So 2 divided by 2 is going to give me 1. 4x divided by 2 is going to give me 2x. Okay. So in this case, we have y equals 1 plus 2x. Again, you can rearrange this if you like. We have 2x plus 1. So I'm hoping you're realizing something here, that these are actually the same problem. So if I start at 1, go up 2 over 1, if you notice we're having the same line here. Okay, so anytime you have the same line in your system, the exact same equation, this is a special case with when we have infinitely many solutions. Okay, because infinitely many solutions would imply, okay, that every point they share on the line, no matter which ones we pick, if they're the ones on our graph, but lines are continuous in both directions, right? So they're going to have infinitely number of ordered pairs that they have in common. So they actually are intersecting all the way on this whole line because it's the same line, one laid right on top of the other one. Okay. So those are kind of our three cases. Now the majority is going to fall into this case where we just have one solution at the intersection point. So like example A. Okay. The two special cases are if they never intersect, then no solutions. And if you have the same line where one lays right on top of the other, where we have infinitely many solutions. Okay. Now, coming back to question 2, it says, what problems can arise when solving a system of equations by graphing? So we kind of saw an issue here when we did example 3a, because when I graphed those, okay, remember I didn't actually know where the point was, I took a guess. So the issue we have with solving by graphing is we have to be really accurate when we graph it. So we have to have really straight lines, okay, and making sure we're plotting our points and our lines very accurately in order to get that correct intersection point. So if you're ever doing it by hand, it's easy to make mistakes doing it using this method. That's why I like using something like Desmos or my graphing calculator to kind of help me make sure I get the accurate intersection point. Okay. So I actually think we're going to end here with these notes because that's kind of the gist of solving by graphing. So you just graph the two lines and look for where they intersect, and that should tell you your solution to the system. Okay. So we'll see you in the next video when we do substitution method.